Welcome, Professor Herges. We're happy to have you here.
Yeah, it was a pleasure to come here. Thank you for the invitation.
Welcome and congratulations on receiving the Adolf von Baeyer Denkmünze.
Thank you.
Your research spans very broad, from theory to synthesis and also to practical applications. Can you say a bit about that and how that came about?
Yeah. When I was young, when I started my career, my academic career, I was kind of obsessed with the idea of changing the world and breaking new grounds. So I started to work on artificial intelligence and machine learning in chemistry.
So very early on then, I mean, everybody's talking about that now.
Yes, in the beginning of the 90s. So I thought this was great stuff. And it was highly published in Science. I even had a science paper. So I thought this is a great success, but unfortunately it didn't give me a job as professor. So German chemical community is kind of conservative. So I had to change my interests, my focus of interest. And I went to the Chemie-Dozententagung 7 times in a row, talking about my research and hoping that I would get a job. And finally it worked. So I remember the moment when I was sitting on the staircase at the University of Braunschweig, opening the letter, finding the call for a C3 position at the Institute of Organic Chemistry of the University of Braunschweig. So this was one of the happiest moments in my life. Mm. Those times I had 3 daughters. My wife stopped working to take care of the children. And my contract in Erlangen was expiring. So the family was dependent on my income. Mm. So it worked out perfectly.
Mm. Mm. So then you took up organic chemistry and started mainly working on synthesis.
No, I did different things. Every 10 years I tried to change the focus of my research. I decided not to do mainstream chemistry and to focus on different things every 10 years. I think this is a good way not to get into a routine and to do new things, to stay creative and to stay young. Mm-hmm. So I did theoretical calculations, quantum chemistry, and I did synthesis at the same time. And my group always tried to combine both areas. Mm-hmm. So we tried to do calculations beforehand, before we did the experiments. So we know the properties of the compounds we are synthesizing before we are making them, mm-hmm. and save a lot of time in the lab.
Mm-hmm. Mm-hmm. What do you think is the secret of good research? Can you say that in 3 words, maybe?
I think, first of all, you should avoid doing mainstream. Try to be creative. Listen to your co-workers. They're young, they're unbiased, open-minded, and if you are in the routine, sometimes you don't think of alternatives to your research. And you need a lot of staying power. Don't give up. And the most important point, I think, is to find the point where you give up. If it doesn't work, mm-hmm. you don't have to give up too early and not too late. So this is a kind of feeling. There's no scientific definition for this point.
Yeah. And you achieved, for example, the synthesis of the first magnetically switchable molecule at room temperature. Can you say a bit about that research?
Yeah. Magnetic bistability is not a molecular property, or used to be not a molecular property. If you look in a textbook of physics, it's a typical solid state property. So, pursue the idea to do something completely new, we tried to find a molecule that is magnetically bistable at room temperature. So we thought about different approaches, and of course the first approach didn't work, picked the wrong one, but the second worked out. So we changed the coordination number of transition metals by combining our transition metal complex with a molecular switch, with a photo switch. So we can switch the coordination state. With switching the coordination state, we also switch magnetic properties. And if you are able to do something new, if you discover a new effect, usually this is also good for applications. So later on, we were more focusing on applications of these molecular magnetic switches.
So is application also something you think about when you're looking at a topic?
No,
No.
Not at the first glance, no. The applications come later. They come, as I mentioned, they are coming automatically. If you have something really new, it's usually good for something.
So how do you find your research topics?
After 2 glasses of red wine.
Okay.
It's inspiring. The third one is too much. Yeah. You can't find it by brute force.
So you cannot sit down and say, okay, now I want to find out.
No. You talk to people, you read papers, and it slowly develops.
And how do you know if an idea would be a good research topic?
After I tried, it doesn't always turn out to be a good idea. If a new idea you have to go to the lab and you have to try. That's chemistry. You never know.
So you said you started very early on with machine learning or AI.
Yes.
So how did you come up with that during that time? And can you say a bit about that?
Yeah. Beginning of the 90s, there was a hype on artificial intelligence and artificial neural networks. And that hype went down, and now, after so many years, the hype is even bigger than those times. So I thought this is a perfect tool to apply it on chemistry, to look for new chemical reactions. Actually, there was a bet with Eschenmoser in Zurich, ETH Zurich. So after a meeting, standing at a bar, we have been discussing if computer would be able to detect or to discover new chemical reactions. And I told him, of course, computers can discover new reactions, and he told me never. This is only a very good chemist can do that. And over the years, I tried to convince them. We discovered indeed new reactions, and the referee actually was Barton, D.H.R. Barton. And D.H.R. Barton, after our first discovery of chemical reactions, told me this is not a new reaction, it's not good for anything. New reactions also has to be applied by your colleagues, and it has to be good for synthesis. So I worked on, but we finally found reactions that are new and can be applied to chemical synthesis. So I have had a phone call with Albert Eschenmoser 2 years ago, and he acknowledged that I'm on that after so many years.
That's nice, yeah.
But he told me after the meeting so many years ago, don't do that. This is not the way to get a position as a professor in Germany. You should just do mainstream chemistry first, and after you got a permanent position, you might pursue your hobbies.
And would you say in the end that this was a good decision?
No, I don't regret anything. No, I think I did it right. And the award that I'm gonna get tomorrow is confirming that. I think this is a perfect confirmation. Yeah.
And coming back to AI, how do you think will things develop now? That
Oh, incredible! At an incredible pace. It's going to change our life completely.
Mm-hmm.
It's also changing professions. The chemists are not ahead because AI is more difficult to apply to chemistry, but other professions like lawyers, for instance, and the whole set of humanities, they will completely change, I'm sure. So in chemistry, it takes another few years, but we also will use AI as a tool.
And if you look at synthesis, do you think that chemists maybe won't be, I don't know, proud that they developed or synthesized this and that molecule? That's just amazing amount of molecules being synthesized by an AI.
Yeah, you are right. It's a psychological problem. The best chess players 20 years ago, they wouldn't predict that a machine would be better than they are. But it's a matter of time, just. And there is no reason why computers or computer programs shouldn't be better synthetic chemists in planning the synthesis, not in executing, of course. Once you go to the lab, you can forget about KI.
So what excites you most about research?
I like to work with young, motivated people. So I'm teaching them how to design experiments, how to interpret the results, try to be good paragon, role model. And they teach me as well. The world is constantly changing, and also their values, their scale of values is changing. So I have to accept that, and I find it interesting, and I listen to them. And this is probably what I will miss most if I'm going to be retired in some time, distant future. I'm going to miss working, interacting with young people. I probably will miss that more than actually doing active research.
Yeah. And can you say in 3 words what drives innovation?
People. Yeah. Individuals, not groups of people and large collaborative projects. It's usually the origin of new ideas can be traced down to individuals. And you have to give them the environment where they can be creative. Don't torture them with regulations and with the course, everyday course. Let them just play around.
And if you could start your career again, would you still become a chemist?
Yes. So I had a choice between chemistry, physics, and electronics. So my first choice was chemistry, then physics, and then electronics. So I could have become a physicist as well, but chemistry more related to experiments, to real world, probably is more satisfying for me.
But somehow you combined all of these 3
Yeah,
parts.
yeah. I studied computer science later on. Yeah.
Okay. So thank you very much for the interview.
Thank you for inviting me. It was a pleasure.
It was a pleasure too.
Thank you.